Hi, I have just created a little recording for my students, and one of my students was wondering, this is in grade 11 in Alberta, how to solve questions like this. So there's a quadratic equal to 0. I think we see a lot of them, and so I didn't solve any of these, but I did an example on the board, and it's this one. In what capacity can 2x squared plus 5x minus 12 equal 0? So I'm just going to cover those up for now because you could do all of those questions with what I'm about to show you. The questions she's on about ask for a graphing solution. So we graphed this parabola. There it is in our graphing calculator. This is just a screenshot here. There's a little bit of the table of values. So just to reiterate how this works, these values go in for x, and the output are these y values here. So if negative 4 goes in, we get a 0. So we have a solution just looking at this screen right here, which is pretty good. And you see that we're actually finding the second solution here. We found this graphically at 1.5. So where is this equal to 0? In other words, where is the y equal to 0? Those two spots. We're going to look at what the graphing calculator does to do that, and then we're going to look at two other ways of solving this person here. Okay, so here's my calculator. So my first step is to graph in y equals to input the equation, or the function, I mean. Then when I take a look at the graph, I adjusted my window a little bit. I often begin in standard window, and that wasn't quite deep enough, so I went to window and I took a smaller minimum value. So then from there I look at the graph and I hit second trace. With second trace I choose 2. And once I'm there, I do the left side and the right side of a particular spot that I want to target on, and the one I'm after is this one. I can do this side the very same way, but this is the one I'm going to show you. So the left side of the 0 is going to be on this side over here. The 0 is here, so this is left. So I'm going to use the left arrow to get on the left-hand side. I'm just going to go as far as I'm pleased to go. It doesn't really matter how far I go away. I imagine it would matter if I went way over here, but in this case I'm on the left side of this 0, so I press enter. The right side, so notice that marker appeared. I'm going to press right. Now I'm on the right side, and there's the other marker. So between these two spots is where this 0 exists. If I just pop right down, and this gives my calculator a little domain in which to search for the 0. And it says guess. Yeah, I do want you to guess. So I press enter again, and 1.5 is the other 0. So we've solved the problem. Over here is the negative 4. We know that from this spot, so our calculator has given us everything we need. But maybe we want to learn a bit more than that. So to learn a bit more, we're going to take this quadratic and we're going to use the quadratic formula, because whenever a quadratic equals 0, you can use the quadratic formula. And there's the quadratic formula, which I like to sing. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so then I fill in what I need. So I just filled in my a value. There's my a value here at 2, my b value at 5, and negative 12 is my c value. I was pretty careful right here with the negatives because I had a negative 4 and then I had a negative 12, which would have made this positive. So I multiplied through there. When I was done, I knew that I needed negative 5 plus or minus 11, because this adds to 121. And then I do a little bit of computation to get either negative 5 plus 11, that gets this one, or negative 5 minus 11, which gets negative 4. Cool. So that's solution number 2. So now we're really good at this. We've got 2 solutions. Our solution number 3 is with factoring. And if you don't know how to factor with a grid, I recommend you learn it. And I've got a video on my YouTube channel. Shannon Sokochoff is my name. You'll see it if you're here. You know what my name is. So I've got a video that talks a lot about these. I think in the title it says something about 12 examples. So I'm going to use that method here. And the first way I do that is to create a grid. This is like a chart with rows and columns. And I place the a term, the squared term, here. I place the c value here, diagonally from one another. So I need to create two values that multiply to 2x squared. And in this case, if I'm going to put an x in both spots, which I kind of need to do if I'm going to be factoring a quadratic, x in both spots, the 2 factors to 2 times 1. So I can put the 2 here if I want, I can put it here if I want. It doesn't really matter. This thing works well. And if I go back to what you know about multiplication, order doesn't matter in multiplication. 2x times x is 2x squared. X times 2x is 2x squared. Okay, so then what I want to do is figure out how I can multiply two things to 12, and I ignore the negative for a while, to multiply two things to 12, and somehow add or subtract to 5. Okay, so I tried, the first thing I tried was 2 and 6 actually. So if I put a 6 here and a 2 here, if I were to do this right in front of you, let's do it. A 6 here and a 2 here. That gives me a 4x in this spot and a 6x in this spot. And no matter how I try, I add them, I get 10. I subtract them, I get 2. I can make negative 10 or negative 2, but either one, none of that is positive 5. So I'm going to get rid of all that. I'm going to need those x's, so I'll just leave them there. I could flip the 6 and the 2, because in this case order matters, because the 2 is going to multiply one of them and not the other. So let's try this. That would be 2x, and this would be 12x. That's 14x, or it's 10x, or it's positive or negative, and no, none of those are what I want. So I have eliminated the possibility of 2 and 6. So the next thing I tried was 3 and 4. So, and not always. By the way, I don't have to guess and test a lot in my own process, because I can kind of see the future in this because I've practiced it a lot, and so will you. But you're not going to have to do 1,000 of them, so guessing and testing is not going to kill you. Okay, so here we go. We're going to put a 4 in this spot and a 3 in this spot, which makes this 6, and this one, which I haven't erased the 2, is going to be a 4 there. Well, that can't be 5 either. But because I've done this question before, I know the next one's going to work. So here we go. Let's see how this rolls. Makes a 3. This makes an 8. And la-di-da. 8 minus 3. Okay, I'm going to switch colors so we can kind of acknowledge that something better than what happened before happened now. I'm going to make this a negative sign. When I make that a negative sign, I realize that this negative up here, negative 3, had to happen in order for a negative product to be here. And that negative 3 nicely helps me make sense of the negative 12. Negative 3 times 4 does equal negative 12. So I have factored this, and because I've done it before, I'm going to show you how that went. There's my 2x minus 3 and my x plus 4. This is all the stuff that I was throwing away when I was doing my guessing and testing, all these guys here. And then right over here, I know something called the zero product law. When two numbers, here's two mysterious numbers, multiply to 0, one of them has to be 0. So this is the reason, the zero product law is the reason why we do this, which I call the grade 9 razzmatazz. 2x minus 3 has to equal 0, then I solve. Add 3, divide by 2, divide by 2. The next one is x plus 4 has to equal 0. I subtract 4 from both sides and I get x is negative 4. So I have the same answer, although this one's a fraction and this one's a decimal that I have here. I have the same answers that I got graphically. There are all my answers there. And la-di-da, I can then go back to this question that my student gave me, and I have 3 ways to unlock those questions. And if you really want to know your way around quadratics and solving when things equal 0, practicing all 3 of these methods with all 4 of those questions would be the way to go. Sometimes, just a warning, this one's not going to work because you won't have the capacity to factor every one of these quadratics. Some of them only have decimal answers, so depending on what level of math you're working on. But you'll always be able to do this, and you'll always be able to do this. Thanks for watching.